Ooh, as x approaching 2. Given the graph pictured below, determine the limit as x approaches 2. When x approaches 2. Okay, that's there. It's positive infinity. It's just positive infinity. Technically, this is still does not exist because if your function goes to infinity, there is no limit. It's unbounded. No limit. No limit. No, there's no limit. You guys know that song? Probably not. It's like on Jock Rock Party Jams. You don't know what that is, I bet. Okay, I'm moving on. That was easy. I'm glad both sides agreed because, yeah, that's an agreeing one. If I go to -2, that would not exist, and you wouldn't put positive infinity or negative infinity because it doesn't agree from both sides. Moving on. Moving on up. Everybody, we're moving on up, like literally up to here. Consider the table with the function for those values as the t gets near 1. From the table, what does the limit appear to be? Well, that seems easy. What are our choices? Look at this. As you approach 1 from the left side, we get closer to 1,000. Positive. As you approach 1 from the other side, from the positive side, from the right side, we're getting close to -1,000. So that would be like this. From the left side, we get to positive 1,000, and then the right side, we get to -1,000. That's an asymptote. It doesn't agree, so the limit does not exist. Sweet. 2 really quick problems. I like it. Select the points on the graph of the function are indicated below. Which of the following statements are true? Which are true? Okay, the limit as x approaches -4. Let's think about this. From the right side. So if we're approaching from the right side, then we have to be a little bit bigger than -4, which means less negative. So that's here. We're approaching from the right side. As we are less negative. Yeah, that's weird. Careful with that. So this goes to it's getting bigger and bigger and bigger. It would be positive infinity. So this one's not right. Don't choose that one. I'm gonna sit up. All right. The line x equals -4 is the vertical asymptote. As you approach -4, this gets really, really small without bound. This gets really, really big without bound. That's the definition of an asymptote. 1, 2, 3, 4. It just means like from the left we're getting really, really negative. From the right, we are getting really, really positive. Yeah, that's the asymptote. Okay, yeah, that's true. And then maybe put a check. I'll put a check. Cha-cha. The limit does not exist at x equals -4. That is also true because both sides don't agree. So, cool, man. Moving on. Determine the limit as the natural log, or of the natural log as x approaches 0 from the right. Let's think about the graph. I hope you know this graph. If not, get familiar with it. Look it up. Know all the details. Just knowing this graph, it helps so much with a whole bunch of other problems. But this is the graph. No, not 0. 1, 0. Yeah, that's the graph. This is an asymptote. So like you'd be able to shift this stuff around in the same ways as normal functions, like using normal transformations. But here, we can say as x approaches 0 from the right side, as x approaches 0 from the right, we are going down to -infinity. It'd be that one. That's the one right there. The way I know this is because from the graph. You could just start plugging in things that are really, really close to 1 and see that you get like a huge negative number. I guess a really, really small number because it's negative, right? Am I right? Okay. Yeah, -infinity. Just knowing the graph. Know the graph of the natural log is useful. Alright. Which of the following statements is true? Oh, I love these because it's like 4 problems. No, I don't love them because it's like 4 problems.
Let's check this part out. As we approach -2 from the right side. Well, if we approach -2 from the right side, we have to be on our function. That's positive infinity. Okay, no, that's not good. The limit as we approach 3 from the right side. What is that? As we approach positive 3? Yes, positive 3 and from the right side. So we have to be on our function. So it looks like we're approaching a y value of -2. That's also not right. I meant to draw that. Okay, so that doesn't work. Approach 0 from both sides. Does it appear to be 0? I think so. Yup. Check that one. Check. Roger. And then x to -2. Okay. -2. That's here. And if it's from both sides? Yes. That actually doesn't exist, right? Because it doesn't agree. This goes to, it looks like -4.5, and this one goes to infinity. So that's not right. From both sides, it has to agree. You know. So it's the only one is that one. You just check all of them. Let's see. Oh, how many more problems? 3 more problems. 3 more problems. Okay. This one's gonna take a while. Determine the value of that. All right. Well, if we just plug in, if we do direct substitution, what happens? Well, what do we get? We get 7 times infinity, negative, plus 2 times infinity squared. Okay. And, well, this is, the way I think of infinity, I mean, it's not a number, it's an idea about, like, it's describing what's happening. So when I think about it and I'm plugging stuff in, I just think a really large negative number times 7. Well, that will be a really large negative number still. Plus, a really big negative number squared, that would be a really big positive number. Times 2, it would be an even bigger positive number. So, we get that. This, by itself, is an indeterminate form because it's the same thing as infinity minus infinity. Indeterminate form. So, this is bad. We have to do some tricks. Limits at infinity, though, we have some different tricks for that. And the same with the bottom. This would be infinity negative, right, for that one. Minus infinity minus 5. Actually, on the bottom, I'm just going to write that for the top. On the bottom, if we have a really big negative number minus a really big positive number, or plus a really big negative number, that's still negative infinity. Minus 5 is just negative infinity. So that doesn't matter. But this is an indeterminate form. We have to do a trick. And the trick, hopefully from the video, was factoring out the highest power from the denominator. So that's what I'm going to do. Highest power from the denominator and force factor that in the numerator. Highest power of x. So, let me write that down. Yep, this video is going to be longer. 7x plus 2x squared divided by the 3x cubed plus x minus 5. In the bottom, I'm going to factor out an x cubed because that's the highest power. So times 3 plus, oh, this is the force factoring part. What is this? X over x cubed, right? Because if I multiply that there, it just becomes x again. So I'm force factoring this stuff out. Really, the trick is just to take whatever it is here and put whatever you're factoring out underneath. Because once you distribute it back in, you get back to this. That's how you can check. Alright, and then in the top, I'm also factoring out an x cubed. I'm forcing this out. So really I have 7x over x cubed plus 2x squared over x cubed. And I'll simplify this out a little bit. Simplify that part. So what do I get? I get x cubed. Well, those cancel out, so I won't write x cubed. What do I have? I have 7 over x squared plus 2 over x divided by 3 plus 1 over x squared. Yeah, minus 5 over x cubed. Now, this was one of the really important limits from the earlier videos. As the denominator gets really, really large, this goes to 0. Same with this. If you could try it in the calculator. If the denominator just grows without bound and the numerator doesn't do anything, then it just goes to 0. So in the top we have 0. This goes to 0. This goes to 0. And we have just 3 in the bottom. So that's 0. No more indeterminate form. That's the answer. Goodbye. That's a 10-minute video. Goodbye. Goodbye. Goodbye.